In this video, I would like to talk about measures of relative standing. And to introduce this topic, I present this situation. So let's say we have three students named Andrew, Kate, and Neil. And we know that Andrew scored 144 on a psychology test. Kate scored 90 on the statistics test, and Neil scored 18 on physics test. Now, who did better? Who did the best of all? Who did the worst of all? Can you answer that question? Now, I would like to remind you that these are not percentages, these are raw scores. So can you tell who did better, who did worse? Or is there enough information? Do you need some other information to make that decision? And most people would say here that yes, we need to know what was the highest number of points available, right? And you would be right. Also, as statistics students, we could ask, what was the average for this test? At least you would know if these people did below the average or above the average. So here's our averages. Here are our averages, mean, right? So the average for the psychology test was 128. So Andrew did better than the average. The mean or average for statistics test was 86. So we see that Kate did better than the average as well. And the average for the physics exam was 15. So Neil also did better than the average. Now, so we still cannot answer the question whose score was the best because we don't know the spread of that data. And as stats students, you may be thinking right now, so we want to know if the score was within two standard deviations, that would be a usual score, right? But if it was beyond two standard deviations, that would be excellent score. Okay, and you would be right. So we also need a standard deviation. So here we go. The standard deviation for the psychology score was 34. So we see that Andrew was within one standard deviation from the average. So close to the above the average, but close to it. Now, 18 standard deviations for stats test, same thing. And 5 standard deviations for physics exam is also this 18 is within one standard deviation. So very close. So we need to be able to figure out precisely how far above the average each score will be. And we're gonna do that. I'm gonna use a different example for that. Actually, I decided to continue with this example. Okay, so let's figure it out. So in order to figure out how much above the score, above the average, was Andrew's score, we're going to find the difference between Andrew's score and the average. That will be 144 minus 128. And we're going to divide by the length of a standard deviation, right? So 34. Let's put this in the calculator. So here I got 0.47, approximately rounded to 2 decimal places. 0.47. By the way, when we figure out how far a score is from the mean, this in terms of standard deviations, it's called a z-score. So I'm gonna write Z and A for Andrew. So the z-score of Andrew's test was 0.47. So let's calculate the z-score for Kate's exam score. So her exam score was 90, the average was 86, and the standard deviation was 18. So for Kate's z-score, we got 0.222. So 0.22 rounded to 2 decimal places. And now let's figure out the z-score for Neil's exam score. So his exam score is 18, the average was 15, so that's 3 points over, divided by the standard deviation. Let's see. So Neil's score was 0.6. If we round this to 2 decimal, that's going to be 0.60. Okay, so now all 3 of these scores were above the average, but how far above the average? So we see that Andrew's score is 0.46 standard deviations above, Kate's was 0.22 standard deviations above, and Neil's score was 0.6 standard deviations above. We see that Neil's score was the highest score relative to the average on that specific exam. So z-score is very useful when we're comparing data values from different data sets with different measurements. Okay, so in general, the formula for figuring out the z-score or the measure of relative standing would be x minus the mean divided by the standard deviation. That's the formula for the population. And if we're dealing with a sample, this is going to be x minus x bar, the mean of the sample, divided by s, the standard deviation of the sample. All right, so these are our scores of relative standing, or rather measures of relative standing.